The principle is, if a process is accomplished in 2 steps, and the first step can be accomplished in n ways, and the second in m ways, then the process can be accomplished in n times m ways. So today I was just surfing the net and I randomly came across a job posting from Google. And turns out they have 5 positions to fill. Okay, so it wasn't random. I went to their careers page just to see whether they are hiring. Now turns out all my friends also applied for the same data science positions. In fact, 100 people have applied for them. I wanted to calculate how many ways can Google fill those 5 positions from 100 applicants. Good thing I know the fundamental principles of counting. Oh, I guess I don't know how to calculate this particular number. Well, maybe I'm not ready to be a data scientist at Google yet. Goodbye, Google. Maybe I'll apply again after I learn how to solve this problem. So I went to my mathematician friend and described the same question to him and asked him how it is solved. He said, dude, you need to learn permutations. Suppose you have n distinguishable objects. For example, the applicants were all separate people, so they are distinguishable. You want to fill k slots with n objects. Or, in other words, draw k objects from n distinguishable objects and arrange them in the k available slots. Remember, you are not allowed to replace the objects in the set of n once you pick them. In this case, n should be greater than k. Also, you can put only one object in one slot. The number of ways you can do this is called the permutations of k out of n. It is denoted as npk. How do you compute this number? Remember factorials? Well, we are going to need it here. So npk equals n factorial by n minus k factorial. So going back to our Google applications and job positions problem. It is easy to see that n equals 100, k equals 5, and Google can fill those positions in 100 factorial by 100 minus 5 factorial ways. So if you write this out, you will see that it is actually 1 into 2 into 3 into 4 all the way up to 100 divided by 1 into 2 into 3 all the way up to 95. So you can just cancel these numbers from 1 to 95 and you are left with 96 times 97 times 98 times 99 times 100. This number is actually 9,034,502,400. If the number of slots is greater than the number of objects, that is, k is greater than n, then the slots can be filled in kpn ways. It is easy to see. The first object can go into any of the k slots, the second in any of the remaining k minus 1, the third in remaining k minus 2, and so on. The last object can go into any of the remaining k minus n plus 1 slots. So the number of ways to do this is k times k minus 1 times k minus 2 all the way to k minus n plus 1, which is the same as k factorial by k minus n factorial, which is kpn. Also, the number of ways you can allot k objects to k slots is k factorial. Let's see if we can solve some problems using permutations. Suppose 4 people board an elevator at the ground floor of a building. There are 6 floors in the building. What is the probability that they will all disembark on different floors? So let's look at the sample space. There are 4 people and each one can disembark in 6 ways because there are 6 floors. That can be accomplished in 6 to the power 4 ways. Now, for our event of interest, that is disembarking on 4 different floors, you have to allot 4 people into 6 slots. This can be done in 6p4 ways. So the probability of our event is 6p4 by 6 to the power 4. Yeah, I'm not going to actually calculate this number. That is, at least one rule is 2. We also know from our definition of probability that the probability of the entire sample space is 1. That at least so to get the probability of our event, we simply subtract the probability of the complementary event from 1. This sounds hard. Do you feel kind of stuck? Should you just quit? Remember your training. So remember, whenever you see problems that ask you to compute the probability of at least one of the cases is something. If the favorable event is hard to compute, try the complementary case and then subtract the complementary probability from 1. So let's look at the complementary event, which is that all 8 people have birthdays in different months. We can compute this probability in the same way that we did for the previous problem. So it comes out to be 12p8 divided by 12 to the power 8. So the probability that at least 2 people have birthdays in the same month is 1 minus 12p8 by 12 to the power 8. Another battle won. Our saga continues. Want to continue the journey? Then subscribe and like. In order to solve problems like above, you need to know combinations.